In this lesson, we'll learn about solving rational equations, which are equations that contain rational or fractional expressions. When we have equations with fractions, we're going to multiply each side of the equation by the least common denominator of all the fractions. This is not new. This is just now extended to denominators that are polynomials. To determine the domain of the equation, we're going to factor those denominators and determine if there are any values of the variable that would make the denominator equal to 0. Because remember, a denominator may not be equal to 0, so therefore these values will be excluded from the domain. So in example 1, what we see is an equation with several fractions in it. However, look at the denominators of those fractions. They're all numeric, no variable expressions. That means they cannot be 0, which means that the domain of this equation is all real numbers. So next, we're going to take a look at those denominators, pick the least common denominator, which in this case is 24, and multiply both sides of the equation by 24. What I'm going to do is I'm going to distribute that times 24 to each of the terms. So x over 6 times 24 over 1 minus x minus 3 over 4 times 24 over 1 equals x plus 1 over 8 times 24 over 1. Now we're going to cancel some common factors in each multiplication, and we can cancel our factors of 6, which will leave us with a factor of 4 in the first multiplication, cancel factors of 4 in the second, which will leave us with a factor of 6, but be sure to include those parentheses, and then cancel the factors of 8, which will leave us with a factor of 3, and again, we have parentheses around that binomial. So now we're going to distribute 4x minus, and remember we're distributing minus 6, so minus 6x plus 18 equals 3x plus 3, once we've canceled those common factors. Next we have negative 2x plus 18 equals 3x plus 3 when we add like terms. Let's subtract 3x from both sides, and then subtract 18 from both sides, and that'll give us 5x is equal to negative 15, and x is equal to 3. Here's one for you to try. Pause the video while you try this one. All right, this one again has a domain of all real numbers, and our least common denominator is 60. Multiplying through by that, be especially careful right here where we have to distribute a negative. So that's going to be negative 12c plus 20. That's probably going to be our most common source of error. All right, let's move on to algebraic fractions. And when we have these algebraic fractions with denominators that are not constants, we face the possibility of a solution that's not in the domain. So if we get a solution that's not in the domain, it's going to be rejected as what's called an extraneous solution. That comes from that word extra, right? It's an extra solution that we get based on our solution method. That doesn't mean we've done something wrong. That just means we got an extra solution. All right. So in this equation, we have two denominators, a minus 1, and when a is equal to 1, that denominator will equal 0. We have a second denominator, 1 minus a, and when a is equal to 1, that denominator is also equal to 0. So our domain is that a cannot be equal to 1, since that will make denominators equal to 0. Notice that they have the same value that makes them 0. That's because these denominators are opposites of one another. And so when we multiply through by the least common denominator, we're going to multiply through by a minus 1. So 3a minus 5 over a minus 1 times the least common denominator of a minus 1 over 1 minus 2a over 1 minus a times that least common denominator of a minus 1 over 1 equals 2 times that least common denominator of a minus 1. Okay, when we do our canceling, a minus 1's in the first fraction cancel the first multiplication, and that's going to leave us with 3a minus 5. And then, when we cancel in the second multiplication, 1 minus a and a minus 1 are opposites. That's going to give us an extra negative. Now we have minus negative 2a, which is plus 2a, equals, and on the right side there is no canceling to do since we're not multiplying any fractions together, so just distribute the multiplication over that subtraction and we get 2a minus 2. All right, from this point, combining like terms, 5a minus 5 is equal to 2a minus 2, and we can move all of our a terms to one side by subtracting 2a, and then add 5 to both sides, and that gives us 3 times a is equal to 3, which gives us a is equal to 1. However, a cannot equal 1, so that means that this is an extraneous solution, which means we're going to reject it, and we're going to write explicitly here that there is no solution, and we're going to box that in so that the reader understands that their final answer here is no solution. All right, here's one for you to try. Pause the video while you do this one. Here's the solution. Note that this one is very similar to the other example in that we have opposite denominators. And we have to be careful to include that factor of -1 in the second fraction when we cancel. And then we do get a solution, m is equal to 2, but notice that it doesn't conflict with the domain because the domain says that m is not equal to 3. So this solution is an acceptable solution, not an extraneous solution. All right, now let's take a look at example 3. In this equation, we have two variable denominators, 5x, and 5x is equal to 0 when x is 0, and 4x, the second denominator, is also equal to 0 when x is equal to 0, so x cannot be equal to 0 is the domain. Next, we have to multiply all the terms by the least common denominator. In this case, the least common denominator is 20x. So I'm going to multiply each of the terms by 20x. Or 20x over 1. Next, we can cancel some common factors. And when we do that, 20x divided by 5x is 4. So that's going to leave us with a 4 times the 6 is 24. And then our 2 and our 20x can cancel. That's going to leave us with 10x. 10x times 3 is 30x. And then in the third fraction, 4x and 20x, we can cancel common factors. 20x divided by 4x is 5. 5 times 3 is 15. And then 20x divided by 10 is 2x. And 2x times 1 is 2x. Now we just have a simple linear equation to solve. I'm going to move my variable terms to the same side of the equation by adding 30x. And then subtract 15 from both sides of the equation. And that will give us, 9. And then dividing by 32, we get x is equal to 9/32. Notice that that doesn't conflict with the domain, which says that x cannot equal 0, so this is an allowable solution. Next, try a similar example on your own. Pause the video while you do this. In this example, k cannot equal 0 because a value of k equals 0 will make the two denominators both equal to 0, and our least common denominator is k squared. When we multiply through by k squared, we get a quadratic equation, which means we're going to have two solutions. I skipped the mechanics of the factoring because I know that you know how to factor a trinomial. 2k squared minus 5k minus 3 factors to 2k plus 1 times k minus 3, setting each of those factors equal to 0. That gives us k is equal to -1/2 or 3. Neither of which conflict with our domain, so both are allowable solutions. In our next example, I'm going to begin by factoring each of the denominators. I'm going to leave a little bit of space so that we can multiply them by the LCD. And n squared plus 4 factors to n plus 2 times n minus 2, the difference of squares. So our least common denominator is n plus 2 times n minus 2. So I'll multiply each of the terms, or each of the fractions here, by n plus 2 times n minus 2 over 1. Setting each of those factors in the denominators equal to 0, we find that n cannot equal 2, nor can n equal -2. So n is not equal to plus or minus 2 if you want to use that shorthand for positive or -2. Be sure that when you state your domain, you are using not equals. All right, now let's multiply. When we multiply the LCD times the first fraction, the factors of n minus 2 cancel, and that leaves us with n times n plus 2. When we multiply the second fraction by the LCD, n plus 2's cancel, and that leaves us with n times n minus 2. When we multiply the fraction on the right side of the equal sign by the LCD, both factors cancel, and that leaves us with just n. Now let's do some distributing. N squared plus 2n plus n squared minus 2n is equal to n. So now we have 2n squared on one side of the equal sign, because our positive and negative 2n add up to 0, equals n on the right side. What we want to do here is to move the terms to the same side of the equation by subtracting n, and then factor, and we're just going to use the GCF of n to factor. Now that we have two factors multiplying together to give you 0, either the first factor is equal to 0 or the second factor is equal to 0. And that's going to give us two solutions. And our two solutions are going to be 0 or positive 1/2. Notice that neither of these solutions conflict with the domain. N cannot equal plus or minus 2, so both are allowable solutions. Neither one is extraneous. All right. Here's one for you to try on your own. Please be sure to pause the video while you do this. Okay, in this example, when we factor the second denominator, we get factors of x plus 2, or either x minus 2 and x plus 3. And when we multiply through by the LCD, we get a quadratic equation. So we set one side equal to 0, factor the other, set the factors equal to 0. We get two solutions, -7 and positive 2. However, the domain states that x cannot equal 2 or -3, so that solution of 2 is extraneous, leaving us with a final solution of just x equals 7. Make sure that you box your final solution so that there's no confusion about rejecting the extraneous solution. Okay, one more example. In this one, we are going to factor each of the denominators, and then we're going to observe that the least common denominator is y times y minus 1. So that means that we are going to multiply each of the fractions by y times y minus 1 over 1. Notice that the denominators are 0 whenever y is equal to 0 or y is equal to 1. So y cannot equal 0 or 1. Again, make sure that you are using the not equal to. Now we're going to cancel some common factors. In the first fraction, all factors cancel. In the denominator, that's just going to leave us with 2. In the second expression, 1, we don't have any factors to cancel since there are no fractions, so we're just going to distribute that negative 1y. So that gives us negative y squared plus y equals, and then on the right, we can cancel the factors of y minus 1, so that's just going to leave us with 2 times y. All right, from here, it will be important that we move all of the terms to one side so that we can factor and find our solutions. I think it's easiest always to move the factors to this, or move the terms to the side of the equation where the squared term, or the highest degree term, has a positive coefficient. So I'm going to move all the terms to the right side. So I'm going to add y squared, and I'm going to subtract y, which gives us a plus y on the right, and then I'm going to subtract that 2 to get minus 2. From here we can factor y squared plus y minus 2 factors to y plus 2 times y minus 1, and that gives us y plus 2 is equal to 0 or y minus 1 is equal to 0, and solutions of negative 2 or 1. However, 1 conflicts with the domain, so that is an extraneous solution. So that means that just y is equal to negative 2 is my final solution. And I'm going to box that so there's no doubt about what I meant for my answer. I'm also going to make sure that that negative there is very deliberate. All right. Here is one last one for you to try on your own. Please pause the video while you do this. All right, this one gives us a similar result to the previous equation. Our least common denominator is x plus 1 times x minus 1. So that means that our domain is x cannot equal positive 1 or negative 1. Multiplying through by that and moving all terms to one side of the equation before we factor, we get two solutions of negative 5 and 2. Neither of those solutions conflicts with the domain, so there are no extraneous solutions and both solutions are fair game.